Alright, so this is our presentation on the SolidWorks design of a Gator. This is for our class DFT 170, Engineering Graphics, taught by Dr. Hans Chapman. And we're in this class of Fall 2022, brought to you by Benny Cabreja, John Zeno, and Allison Kneedler. Alright, so for our reference model, we decided to go with the John Deere Pro Gator. The reason being because it actually has a manual lift bed on the back, so you could situate it to different levels, making it much easier to design. Alright, so for our sketches, we actually, right from the start, we decided to put in our dimensions. Some of them were subject to change because of unforeseen circumstances, but most of them stayed similar. You can see that we actually have all 5 parts modeled out right from the start, and yeah. Alright, so for our first model, this is actually the body, the main body, and we decided to include the indents on the bed for you to be able to select different levels of height for the lifted bed. And then we also decided to include the wheelbase actually onto the body because it makes it easier for the wheels to just pop on, pop off as needed.
This is our body. The only thing that we weren't able to do was make it a square. So what we did was we rounded the edges. On the bottom part, there are 2 separate squares that have a bar in between to hold our pin that you will see in the future. The bar is acting as an axle, holding that pin sturdy. The wheels are very straightforward. There's not much you can get around. All it is a circular wheel with a hole for an axle to go through. The only thing that we had to worry about was its material for it to not deform when having the amount of force from the truck, gravity, and newtons pressing down on it. This is our pin. Even though it was being so simple, it was one of our hardest designs for us to think of. We wanted to make it so real life scenario that we definitely maybe overthought it at the beginning, but it turned out in the end with the hole at the top of it for the axle and a point at the bottom for it to glide along the bed of the truck until it will hit an indent. This is our cylinder rotator. This is acting as an axle for that pin at the top, at the bottom of that bed that will be connecting those pieces together. This is also quite straightforward. This is our assembly. The only 4 parts that we have are the body, wheel, pin, and bed. The bed is made of a polycarbonate plastic. The pin is a heavy steel, along with the body also a heavy steel, and the wheels are a silicone. This is all of it together as the pin glides along the bottom of the bed and will eventually get caught into an indent when the bed is at its maximum height.
This is our drawing document. You can see our front, side, and top views, while the isometric view allows a 3-dimensional view so you can apply it to real life and see how this would actually be used for job sites, work sites, and you can kind of see how this thing could be used for carrying loads anywhere you need to go. For our simulation, we decided to put the forces on the wheels, and then you cannot see the arrows, but we decided to put them inside the bed for gravity and also for whatever else is inside of the bed. But the arrows on the wheels are for the normal force from the ground and gravity acting upon it from the weight of the entire object. And this is our animation. I don't know if we can play the video.
In conclusion, the most important for this project was definitely having good teamwork. Very lucky to be working with people who want to be a part of this, want to help, want to communicate with you. That is very, very important. We definitely used our resources, asked for help, but brainstorming and simulation took the most amount of time. Because these parts were so individual and the Pro Gator was only a reference guide, brainstorming took the most amount of time out of this project. The simulation, we all came to a conclusion that it was the most important and most resourceful out of all of these things. If we were to redo our project, we would definitely use our simulation to change our products, to change our materials, and make our product a better thing than it is now.